Hello, in this episode we're gonna take a look at the find and wait methods and also how to walk the tree with WalkTree method. And today we'll be playing with Notepad again. So the first find method we've already used is FindElement. And a close relative to it is the method FindElements in plural. So if FindElement either finds an element or throws an error, then FindElements finds all the matching elements and returns an array of elements. So we can loop through that array of elements by using a for loop. For element in elements, we can highlight an element. So here we got exactly one element. However, if we change this to a menu item type, then it should show us all the menu item elements. So it goes file, edit, format, and so on. We can also get the index of the element. So if I loop through it like this, I can access from elements and use the index instead. And it works the same. FindElements doesn't have an index argument because it starts from the first index always, and it has the scope, border, starting element, and cache request, the same as their normal find element. If no element is found, then it returns an empty array. It doesn't throw an error. So in this case, it simply didn't highlight anything. If we wanted to know how many elements were found, then we can use the length property of the array, and it shows how many elements were found. In this case, there were 6 elements. So if, for example, we wanted to check whether we found anything, then we can use if elements.length, and if something was found, we can use a message box, for example, to display that yes, something was found. In this case, nothing was found because no group element exists, but now we did find something. The next one is element exist. Element exist either returns an element or returns 0. So if FindElement throws an error, then element exists checks whether there is an element. So we can use it in an if clause, and if an element exists, then only then we can highlight it. And an element with type group didn't exist, but if I use type document again, then it highlights the element. So this way we can avoid errors thrown by FindElement, because if we do this, then we get an error message instead that no matching element was found. Then we get to the next one, WaitElement. WaitElement uses almost the same arguments as FindElement, only that it has the timeout argument as the second one. So it simply waits for an element to exist, or it throws an error that no element was found in that time. So I can wait for a document type element, or I can wait for a group type element, in which case it simply waits and waits and nothing happens. So if I set the timeout to 1000 milliseconds or 1 second, then after 1 second it returns 0. WaitElement can be useful if we have recently clicked something and we are waiting for an element to appear. So for example, here in the UIA viewer, we have this combo box right here. So if we inspect this window, then this action doesn't have any childs. So it only says button open. However, if we inspect it again, then we see that we get the list item elements, click and dump and all those other ones. We can do the use wait element there after clicking the combo box open button. So for example, let's change this to UIA viewer. And let's find element. It should be the name. So it opens the menu. Now, if we wanted to click something, then we could simply use wait element to wait for an element with the name click. So it waits for the combo box to expand, and once the element exists, we can click it. So here we see that it found and clicked the element. We can also wait for an element not to exist. So we can wait element not exist. So this waits until the element disappears. We could, for example, click the selection item. So we wait element exist. We wait element, we click the item, and then we wait for the element not to exist, in which case we know that the element has now disappeared. So let's try this. So the tooltip went away too fast. And we see that the element disappeared. Okay, the next one is ElementFromPath. ElementFromPath uses one of the paths specified in UIA viewer. So for example, here we see that the combo box open button has an UIA path of 30. And if we wanted to get that element, we could simply use ElementFromPath. So it highlights the open button element, the same as before. We can also click it in the same manner. And if we wanted to select the list item again, we can use its UIA path to click it instead. So we can use WinL.WaitElementFromPath as we used the wait method before with WaitElement, and we can click it. So here it selected set focus and clicked it. So UIA path is less trustworthy than using FindElement. This is because it's actually using a combination of types and indexes. So for example, if we start from the top, we see that the UIA path is empty. Then the next one is 8. The next one is 8/n, and so on. And the deeper we get, the more of the path we see. So this actually means that UIA is simply traversing element by element using the element's type. But if the order of the elements changes in the window, then it won't work anymore. So if I were to add something in the tree, then it might break altogether. Another option is to use the condition path, which uses also types, indexes, and also automation IDs and class IDs and names. So we could copy it by left-clicking it, and we could use this path instead. So this was the set focus. We can replace that UIA path with this, and it works the same. So in this case, it's simply some shorthands for type is number 3 is a combo box type, and so on. So this kind of path can be used as well. Usually the path is a little bit faster than FindElement because it traverses very little of the tree. So in the case of FindElement, if we try to find the set focus or click, then it would have to traverse all this tree before getting to it. While the UIA tree simply starts from this, looks in the window children, but not the descendants, and finds the combo box, then finds the list action, and then finds the list item. So this way the search is much faster, since it's only looking for about a total of 10 elements or so. We can also use ElementFromPath with a shorthand with an array syntax. So if I use WinL and use the square brackets, then this accesses the UIA path as well, similarly to ElementFromPath. Okay. In the same manner, we can use the numeric path as well. So if we change to display numeric path, then we see all the numeric paths which are pretty much just index of the child, and then the deeper we go, we get comma separated childs. So in this case, this is the second child, and this is the second child's first child, and so on. And we can access these childs in the same manner. We can click them or highlight them. And we can simply get, for example, the first child or the fifth child. And we can also use a negative number to get the child from the bottom, or we can get the last child. So in this case, it would be the last child in this tree, which would be the title bar. So this -1 got the title bar element. Or we can even go deeper and use this in the same manner. The next method we're going to take a look at is WalkTree. We can use this method to move around in the tree, starting from the element. So we're going to start moving from this combo box action element. This is this element right here. So if I highlight it, then we see it gets a red border. And we can walk the tree. We can walk either to the next element, the previous element, to the siblings, or to the parents. So shorthand for next element is plus and the number of elements we want to move. So in this case, it's gonna get the next sibling element, which is this add element right here. So let's see if it gets it right. And it does highlight add element. And if we were to move 2 siblings further, then it should get to this document element. So let's try that. And it does. We can also move to the previous sibling by using minus and the number. And we can get to the children as well. So for example, if we remove the plus and minus, then it goes to the child instead. So in this case, I think we should move to the second child to see the open button. We can also move to the parent. If we write a letter P here, then it moves to a parent, which is the window element itself. We can also use a number after the letter P. So instead of going to the parent and then going to the parent and so on, we can simply use parent 2 or parent 3. So if we, for example, move to the first child and then 2 parents upwards, then we should again get to the window element itself. Here we also combined multiple moves. So I can go to the first child, and if I put a dot here and, for example, +1, then it goes to the first child and then to the first child's next sibling. So that is the open button right here. WalkTree also has a way to normalize. Normalize means that WalkTree starts from the element itself, checks it for a condition, and if it doesn't match, then it checks the parent of the element or the parent of the parent. So if we start from any element inside the window and we normalize to type window, then in that case, we always get to the window element, no matter where we start from. So even if I start from deep inside the tree, somewhere here, then we still get to the window element. Because it checks whether this element is of type window. It's not, so it looks at the parent. It's not, so it looks at that parent, until it gets to a window element, so it gets to the window itself. This is useful, for example, in browsers, because you can start from any element inside the content and get to the document element to, for example, get the web page URL. So we use the condition to normalize to an element, but we can also use a condition to simply walk the tree. So if we wanted to, we could filter for type button elements and walk to the next sibling element that is of type button. So in this case, we are still starting from this button right here. And if we walk to the next button in the tree, then we see that this column left button should be the next one. And indeed, it gets highlighted. The problem with this method is that it can actually walk out of the tree to the next one. So if I put a big enough number here, then it can actually highlight something in another window. In this case, the next window is VS Code, and it walks the tree to this one. And there are also find methods for cached elements, but we are going to take a look at those in the caching video. So this is it for now. And in the next video, we're going to take a closer look at patterns. See you in the next one.